Okay, welcome in everybody. Thanks for cutting out some time of your schedule today to be with us. Looking forward to the webinar. We're just going to give it a couple minutes here to let more people join in. I'll probably go over this a couple times while that's happening, but just some housekeeping really quickly. You're going to see a few buttons and options at the top right of your screen. One of those is a chat looking kind of message box, and then there's another box to the right of that that's called questions. It's just a box with a question mark in it. If you want to ask questions during the webinar, which we motivate you to do, please use that questions box. The chat one isn't really functional. So let's maybe test that out real quick. Can you guys go into the questions box and just enter what state, city, country, province you're from, and we'll make sure that's working. We got Minneapolis, St. Louis, Ontario, New Mexico, Missouri, Florida by way of Oregon. Nice.
That's what I read too. I was like, what a trip. What a trip.
Oh, Brian Doyle. What's up, Brian? St. Louis, Mississippi. Cool. We got people from all over the place. This will be good. All right. I'm just going to give it a couple more minutes, guys. We got a bunch of people joining in here, so. Perfect. Okay, cool. Looks like we got a big chunk of people just joined in. Again, use that questions box, not the chat box up there in the top. As we go through the webinar, we definitely like these to be interactive. So please, if you have questions throughout this thing, put them in there so we can answer them. If it's really relevant to something we're discussing in the moment, we may answer the question in real time. The majority of the questions, we're going to save pretty much the last half of the time block here just to answer and do Q&A. So a question in there and no good immediate answer. Don't worry, we're going to get to that shortly here. So yeah, let's start it off. Today, I see a few familiar names and faces in here, some new ones too. But today's going to be all about how to produce high purity THCA at scale and a lot of things related to crystallization in general. We've got a great team here to present today. And if you've seen this webinar before, excited for this one because we've got a bunch of new stuff to show you related to this topic that we're excited to dive into with Art and Murphy here as well. So before we really dive into things, these webinars evolved solutions. We're an OEM equipment manufacturer based out of Toronto, Canada. We also have a US division now. We help clients increase profitability and pretty much just solutions for anything related to their extraction processing. We do full system facility build outs. What we're really going to focus on today is the crystallization side of things. So what we really do is pretty well known for is our controlled crystallizer and controlled crash method. We'll be getting into that today. Bottleneck busting module integrations. The crystallizer could be considered one of these. But something unique to Evolved is we can come into your facility and add our modules into your existing extraction equipment without having to reinvent the wheel. So this creates a good pathway to a lower capital investment solution to bring your system up to 2026 tech or add functionality, add efficiency without having to have a bunch of downtime, buy an entire new extractor and reinvent the wheel basically. In addition to that, we do full turnkey system and facility build outs, and also consulting, training, seminars, and other engineering services. When it comes to the consulting, the training, and the seminars, obviously we do these webinars pretty frequently. I'd say once a month probably at this point. We're talking about doing some live demos at the facility. We usually block those out at our research facility that Hart's currently at in Guelph, Ontario. This is a really nice resource for clients because it's in Canada. We have an R&D license at this facility, and we're able to do demos with actual biomass. This also allows us to do iterations and R&D things pretty rapidly before we release any products to market. If you'd like information about coming up for a demo, we don't charge anything for this. They do book out pretty quick. We have a block typically at the end of every month we do these. That same questions box we talked about earlier, just drop demo or type demo into that and we'll reach out to you with some more information. Even since I've just been talking, we had a bunch more people join. So just some housekeeping again really quick for the new people that just joined. two buttons up in the top right. One's a chat window with two little chat bars there. Ignore that. There's a box right to the right of that with a question mark. That's where you can ask questions and contribute to the webinar. If we ask you to type something, if you're interested, do it there, or enter your questions as we go through. The first half, we're going to go through the presentation with our team here, and then in the final half, we're going to reserve that for Q&A and just have an open dialogue with everybody in the whole webinar. Okay, so moving on. I'll let Murphy speak to this. Actually, this is an Instagram poll that Murphy did relative to how many people are basically modifying their systems out of the box anyways, and it'll become apparent why this is important. But Murphy, do you want to shed some light on this poll you did?
Yeah, so this is, especially back when I did this poll originally, is kind of one of those Fight Club secrets of the industry where everybody knows that we deviate from our peer review or from the manufacturer's recommended setup. And sometimes we deviate for like legitimate reasons that just happened to play out during your build out, or during your licensing. Maybe the equipment you bought was a generation older than ideal, and so you tried to upgrade it yourself and catch up. There's so many reasons. Some of them are good reasons, some of them are less good because people are trying to be creative or trying to be economical, but fundamentally everyone was changing their extractors. And I know this firsthand from selling people extractors directly. Swiss and I back in the day selling our little baby extractor with that 1-2 pounder. Yeah. But I also know this from consulting and going out and helping people, because fundamentally no manufacturing industry operates on a one-size-fits-all skid. And the idea of an all-in-one packaged skid that's ready to deploy, which was really the tagline for a lot of closed-loop manufacturers for the past decade, everyone wanted to sell you an extractor in a room ready to go. And that implied that they knew what you needed. And unfortunately, if you didn't know what you needed, you probably bought that and then found out afterwards that you needed more, you needed less, you needed different. And so I tried to get some data together, in part to bully these equipment manufacturers into taking feedback, because fabrication is hard work, y'all. And I appreciate what welders do every day, but it is not that easy to make a significant change to the system and roll it out when you've built your business around packaged identical skids. However, in normal manufacturing, you'd have an engineer on your team who'd be able to update your own peer review whenever they needed, whenever they wanted. And so the cannabis industry is in this strange moment where we are right in between real manufacturing, where we would have real engineering teams that are dedicated to optimizing and solving all of our problems, and the sort of hobbyist, early small business manufacturing, where people were really doing almost like a cheap restaurant version of a build out, where we're just buying the equipment that everyone buys and using it the best we could and hoping that our chefs were talented enough to make it work. And so the point of this poll was to get some of these manufacturers to listen to the operators. And that is how I met the people from Evolved. Prior to that, I was like, this is just a CRN hydrocarbon company, which is important. Not everybody's willing to do the CRN work, but it's also, I think it's one of the most unique things about Evolved is that if you know me, I love to complain. And I do it anyway, but a lot of people don't listen. And Evolved listened. And so that's one of the most exciting things for me about this poll, is not just that everyone, was willing to share a lot of details about what they're changing, but also that most equipment manufacturers have modified the way they pitch their systems since this poll was released almost 4 or 5 years ago now. And Evolved was, the first to show up and say, what's up with this? Nobody likes their extractors. And it's not that we don't like them. It's just we need a little bit extra. And modifying it for what your goals are is really, what I help people do as a consultant, but I can only get it so far. We still need the hardware, and we need the hardware to be good and safe and ideally peer reviewed and approved by your local authority having jurisdiction at the end of all that.
Right. Thanks, Murphy. Appreciate it. So today's itinerary, guys, we're going to do some introductions here in a second, and then we're going to get into why do we crystallize, ingredient manufacturing, formulations, and primarily purification. Crystallization is nature's way of purifying compounds. So stoked to have Murphy and Hart on with us today to really dive into some more of the technical science side of that. And again, if you've seen this webinar before, we've added a bunch of new content to this to kind of show where we were at and where we are now. So really excited to get into that with everybody. Crystallizations in general, crashing versus growing. So, large scale THCA isolate production versus larger diamond growth, kind of where everybody's at with that right now. And four, how do we crystallize at a small scale in glassware, at a medium scale in something like diamond miners, or at a larger scale in something like a reaction vessel or the controlled crash crystallizer. We're going to look at here shortly. Moving to intros, we'll just kind of go left to right if you want to do a brief intro and start off, Murphy.
Yeah, I'm Murphy Murray. I'm a extraction consultant. I work with people on designing their process, designing their equipment, optimizing it after it has been designed and installed, and especially on product development within the constraints of your equipment. So while I can't sell you a stainless tank directly, I can help you figure out what size that tank should be, why you probably need 2 of them, and help you balance who to buy from, depending on what that tank is going to do. Some tanks need to be pressure rated. Some of them need to have lots of fancy supplies. All of them need to have thermocouple probes. So, my role in all of this is in between the regular business owner who has to focus on productivity and production and hopefully profit, and then the manufacturers who really like clarity when they're trying to come up with a process and deliver on an order for you.
Right. Thanks, Murphy. Hey guys, I'm Eric Wilhelm. Everyone just knows me as Swiss in the industry. I'm a senior account executive here at Evolved Extraction Solutions. I'll be kind of moderating the webinar today, contributing where it makes sense, and just keeping us on track so we have time for the Q&A stuff. Moving over to you, Hart.
Everybody, I'm Hart Slater-Eddy. I'm a chemist by trade, and I work in the R&D department here at Senti Solutions. So basically every day I'm just sort of in a booth running a bunch of crude through a crystallizer and trying to optimize the process, dial it down bit by bit, make sort of small incremental improvements. And I hope I can sort of show you what I've been working on recently today.
Awesome. Thanks, Hart. Okay, moving on, guys. So to relook at why we crystallize, we can get lots of different products out of crystallization and HTE separation. We were having a good conversation about this kind of in our pre-webinar meeting yesterday. A lot of good points were brought up on that. Murphy, Hart, if you want to kind of take charge on discussing, how the benefits of this works out, that'd be great.
You want to jump in, Hart, or I can speak about it from the consumer end?
Yeah, sure.
So,
you go ahead. Please do that one.
Yeah, so I'll start real quick and say, the cannabis industry, again, very exciting and unique for manufacturing, because it is one of the few industries where consumers bring us a product format and SKU, and then we develop a process to produce it. Most other industries come up with products and then pitch them to you as a consumer, but the cannabis industry, it's not quite a feedback loop. It's not perfect, but it does come from the bottom up a lot more often than other industries. And one of the hardest things to do in this industry is to standardize and to replicate things that have worked in the past. We're pretty good at replicating failures, things that we don't like, very easy to do again, but replicating things that work has largely been based on blaming genetics and growers, I think is the standard for the extraction world. And one of the greatest benefits of crystallization is to no longer be tied to the input material and have that control the trajectory of all the products that you can make. For many years in the cannabis industry, we had fooled ourselves into believing that whatever happened to us and that we were very passive in our control. But crystallization allows us to break the product down in a way that is so much more robust than removing trichomes from the plant material, which, you know, was already hard to do perfectly every time. Now we can not just remove the trichomes, but break that little chemical factory down into all of the individual components, which prepares us to respond to whatever the market needs. Because the shatter that was groundbreaking in 2013 is still on the market today. And the labs that make it also need to make liquid diamonds and also need to make live resin and also probably make rosin vapes. And it's a burden to make a ton of different SKUs. And so to keep these extraction labs from turning into your local diner with a 26-page menu who does a pretty average job of everything, crystallization allows you to customize and specialize without having to have a different skid for every single product that you make.
Yeah, I like to add on to that too. That's a great point, Murphy. And something we've really seen our clients like transcended even into their kind of business modeling is now that they have the ability to kind of just do this ingredient manufacturing style processing where we're really just making THCA and fractionating the HTE off of it. We're just making these two ingredients now, which simplifies all your primary extraction SOPs to make some of these other products in the past or now. We're changing the parameters on the system. It's a different SOP to run the system for live resin than it is to run crude from old trim or whatever it may be. There's all these different processes and stop gaps and areas where problems can come up. If we're just crystallizing and making HTE and doing all of the formulation work on the back end, the primary extraction becomes much simpler now. And we're also moving to this ingredient-based manufacturing model that's similar to like just-in-time manufacturing, like Toyota's whole concept of manufacturing. You can have very tight control over your output based on what the market's demanding. So we don't have a ton of extra material laying around or not enough laying around. And THCA and HTE are pretty stable. Like keep them in, good containers in a dark room, and they can last a long time. So we've been seeing that change with our clients a lot, is moving off of these old processes and really harnessing crystallization and HTE for those purposes as well, among other things we'll get into in this webinar. But yeah, I just wanted to add that point. Did you want to add anything to this one, Hart, or move on?
I had one quick thing I was just going to mention. The thing that I love about moving away from sort of producing your individual different SKUs and moving towards just crystallization and having the HTE sort of separated out, right, is that you're able to say, we're going to be talking about THCA today, but obviously I could be talking about any other cannabinoid, right? But I can say, cool, I love the flavor of this strain, but the THC content is too high or too low for me, for what my clients are looking for what I want for my own consumption. And I can blend that back in with the THCA in a different ratio to sort of make these like almost like boutique level, like pharmaceutical level products where you're essentially producing something exactly like what the client wants. I sort of dream in this industry that what we can get to is you walk into a shop and they say, okay, you're looking for something that's like 50-50 CBN to THC, and you want it to have a lot of limonene in it. And they basically say, here's 3 HTE options, smell them, see what they smell like, punch it into a little thing behind the shelf, and then formulate it up for you, mix it up, throw it into a little cart, just like that.
Right. Absolutely. Thank you, Hart. Yeah, moving on to our next slide here. Hart put this together from world analytical figures, it looks like. If you want to dive in and explain what we're looking at here, Hart.
For sure. So this is just a case study. Since we're an R&D outfit in Canada, we are able to receive Canadian clients' biomass, run it for them, and sort of give them actual full mass balance accounting of their process from start to finish. That's talking like out of the freezer into the sock with the biomass. This is dry trim for this specific example, all the way to HTE and THCA in hand, which you can see in the middle and right photos there. I'll just talk you through this briefly. At the bottom is the COA for each of the corresponding photos above it. And so the initial dry trim, we ran just over 27.5 kilos. The initial THCA content was 11.5%. We extracted down to 1.38% weight by weight, which is a reasonably good extraction efficiency. I find that it is not effective to go beyond that personally. We won't get into that here. But basically, then that generates our crude, right? We boil that off. I don't have an image of the crude because we keep that in the system so that we don't have to remove that, boil it off, get a tare weight, put it in a vacuum oven, do all these sorts of things. It just gets to stay right in the system. And the same day, I'm able to start a crystallization and finish it, where I was able to get 2.04 kilograms of THCA, pure to a purity of 98.45%, which I calculated from, you see the COA on the right there. I realize it says 99.99. And that's a great number to get in theory, but I think we can all understand that all that's telling me is that my THCA there is more pure than the standard that analytical lab used, right? So that speaks well to my ability to crystallize, but it doesn't mean I got 99.99%, right? So what I did instead is I took 100% and subtracted away the other minor cannabinoids that were present, being, delta 9, THCVA, and it looks like CBGA in there, right? That afforded us a yield of 64.1%, and that's a number that we can reproduce time and time again from biomass directly to THCA. We are always hitting between 65, let's call it 62, 63, and 70% THCA from the plant. Varies strain to strain and fresh frozen, dry trim, these sorts of things. And then I just put some HTE numbers in there just to show you we get sort of a, let's call it a 5-to-3 ratio of THCA to THC in our HTE, which is reasonably good, I think. I'd love that to get that down to 1-to-1. That's the best I've been able to achieve, but it's not always going to be quite that good. And so that means we left about 800 grams of THCA in our HTE. But we have an idea of how to solve that problem in the future. There's sort of two ways we could go about it, whether we're talking chromatography or whether we're talking membranes. But yeah, hopefully we'll have something to present in a new webinar soon. But I just wanted to sort of show this as a case study to say, okay, we can start with under 30 grams of 11.5% dry trim, and we can give you at the end of the day just over 2 kilograms of THCA, and we can do that day in, day out, right? It's sort of a nice little case study to put some hard numbers behind what we're about to talk about here.
Yeah, one thing I want to, one thing I want to point out in the COAs here, and I love to see the COAs. I always ask people what their COAs look like for their material before we even start the crystallization. And there's a lot of things I want that information for. I'm very greedy when it comes to data, just send me everything you've got. But when I look at the material, kind of in the same way that you might judge literally the weed in front of you when you're thinking about starting this crystallization, I always look for how much delta 9 is in that flower before you even get started. And that's, I think, the number one difference between fresh frozen and dry material in processing. I remember a period of maybe almost a year where people really thought you couldn't crystallize dry material. And, I had a call with someone literally this week who's crystallizing from their fan leaf, which, it's not my first recommendation, but you can, right? And what's important is setting yourself up, for success in part by having the tools you need and a process that works, but also by having reasonable expectations. And so when I see that delta 9 presence in the dry material, that almost always leads to more THCA in your HTE, because delta 9 is a contaminant to the THCA crystallization process. CBD taught us, just how much we could get away with, because in the world of hemp crystallization, I would say largely everything that we're saying today cross applies to CBD, except that everything about CBD is going to be easier, right? And so because CBD crystallizes in its acid form and its decarboxylated form, piece of cake. one of your greatest obstacles in the separation process and, you know, looking to what you can expect your final yield of crystallized product from that dry, fresh frozen, fan leaf, whatever flower is, you know, what are the contaminants that are going to show up that you have to fight against? What are the other things that want to crystallize with it? So, you know, sometimes we can't get over 99% on dry material because it's really hard to compete with the waxes that are in there. And it's really hard to get all of the THCA away from the Delta 9. But in fresh frozen, I actually see that it's hard to get over 99% because there's always CBG. And the CBGA wants to crystallize too. And so, you know, keeping track of your testing throughout, and truly the more tests you can do at every stage, the better this process will get. And I think this is where everyone has the most opportunity to customize their equipment. The process is inherently, structurally the same, but you know, how much you process at a time, how much you crystallize at a time, how quickly you approach a temperature ramp, how many times you anticipate needing to rinse and repeat a step in the process. A lot of that can be predicted from your original flower COA. Someone in the Q&A asked, you know, doesn't the strain matter when you're dealing with, you know, how much or how you approach removing these cannabinoids and crystallizing them? And I would say that the strain matters only in so much as that the input matters, you know, having that data. And so some strains might be more likely to have a lot of CBGA. Some strains have a lot of THCV getting in the mix, being all sticky. You know, some strains are old, poorly cared for, and have been in a super sack in a hot warehouse with, you know, variable humidity for a year. And so all of those factors, I would say strain matters as much as storage, as much as, you know, age, as much as cultivation method. And so it's not necessarily ever going to be true that some strains crystallize better than others because of their genetic lineage, but more so because of what compounds were available to us to start. And so this data matters, but I think it matters the most when it fails. If you ever have a batch where your HTE keeps crashing, and you can never get over it, oh boy, I want to see what that flower tested at. And flower testing for terpenes is terrible. It's not very informative because it's hard to see everything when it's available in very small quantities. But the more you can test that HTE for everything, potency, volatiles, the more you can test those, you know, crystals in between stages, the better. And sometimes the testing is sending it off for analytics. Sometimes the testing is popping it under a microscope or trying to redissolve it in acetone and see how much of it winterizes rapidly. You know, sometimes the tests are something you do on your own, but a lot of it can be fairly accurately predicted from that original biomass test. It's a really key component. And I think a lot of people dismiss the biomass testing in part because of the variability, but also because it happens right after harvest. And, you know, it's in most markets, an R&D test is $25 to maybe $50 in the most expensive states. I can't speak to Canada, but it's worth it. Like, go and test the material you have in the condition it's in before you start this process, because you can crystallize anything from anything. But how much effort you're going to have to put into it to get that yield is largely going to be determined by what you were starting with. And it's not just how much THCA was there. You know, a lot of times I'll hear from people it was high potency material. Probably high potency contamination too. When, you know, when it has a lot, it has a lot. So this data is really helpful even when it's bad news.
Right. Great point, Murphy. Do you want to add anything else, Art? Are we okay to move on?
No, I think we can. I think that's great. Thanks.
Cool. Moving on, and before we dive into this, just a quick reminder, it looks like we had like another 10 or 11 people join in late. For the new people that came in, the questions box up at the top, not the chat one, but the little box with the question mark inside of it. Please feel free to ask questions, make comments, just use that to do it. The chat one will not work. So yeah, sorry about that. Just want to let all the new people know that. Yeah, so moving on now, we're going to be looking at crashing versus growing. So more of the large scale THCA production versus growing crystals. So growing crystals is a slow, controlled growth process method. Crashing amorphous crystals is a fast forced precipitation, which I'm glad you put that precipitation word in there, Hart. The objectives are different. The objective of growing crystals are well-formed, large defined crystals. In crashing, we're looking for quick, small, amorphous crystal formation. And the methods vary as well. So the methods in growing crystals are going to be gradual adjustments of temperature and solvent, and crashing, fast adjustment of temperature and solvent. There's some images down here. You can see some diamond miners on the left of these larger crystal growth formations, and more of the isolate HT separation here on the right. I'd be curious if you guys can drop in the question bar too. Like, are diamonds still a big thing in your markets? Like, I see them. Some markets
I just
are
asked
holding
Lisa
on
Mar to
them.
put a poll together for us. So if everyone,
Yeah.
I think she's going to launch it in a second here. If you guys
Oh,
could all
cool.
just
Yeah.
kind of chime in and let us know, what are you making with this THCA? Because I think especially on the equipment end, we have a lot of conversations about how to get real high purity, real high yields, really fast. And then we kind of don't have to finish the conversation to talk about how the post-processing plays out, because everyone has their own special sauce. And a lot of times they don't know, they're going to make a lot of different things. And so, refining that process is kind of after the fact. But I think it'll be interesting. Like Swiss said, I remember a time when people wanted one big, 0.9 gram diamond with a little HTE on it. And,
solvent in it.
I can't say I've bought a gram that looked like that in a long time, but there are still markets for it,
Yeah. Thank you guys too. We're getting a bunch of good feedback on the poll. I don't know what it looks like on everyone else's screen, but the poll may have took over the presentation. Are you guys seeing the same on your end? Okay, cool. We'll let this poll run for like another 10 seconds, and then we'll end it and share the results so that we can go back to the presentation.
Yeah, I see a lot of people kind of going in the same direction of like isolate and ingredient manufacturing.
Yeah, while we're waiting for the poll too, Chad Boyer, thanks. Yeah, he put something in the question. He said, in Missouri, diamonds were popular for PR giveaways 2 years ago, but doesn't see them much more at all anymore. Some labs are growing for size, but just a few. He hasn't touched his miner in like a year, he says.
Yeah.
So I think that's kind of the common theme I've been seeing too, is everyone's moving more to this, isolate production for the reasons we've been talking about, plus some. Yeah, I'm going to end the poll so we can get back to the presentation. I'm going to hit this end and share results so everyone can see. Everyone should be able to see, but yeah, it looks like, isolate 60% disappeared on us. We'll share that later too. And just for anybody that joined in later, anybody that would like it, this webinar is being recorded so you can watch it later. If you do want a link to view the recording, just type recording in that question box and we'll make sure to get you access to that after we finish up here. Cool. Yeah. So moving on. This is good. These are temp over time graphs basically that show like kind of the differences between what we're doing in both of these processes. Hart or Murphy, do you want to talk to the different kind of ramp downs here between growing crystals and crashing?
Yeah, I can give a little spiel here, I think. So when you're actually trying to grow crystals, what you're trying to do is basically have a very slow and controlled process, right? You can imagine like you're slowly trying to lay the bricks on a house. You want all those bricks to be spaced just perfectly. You don't want your house with bricks all at jaunty angles, right? You want them to really, really slowly be built up, just be spaced just so you can actually wind up, if you've grown your crystal properly, with a single crystal quality crystal where you could actually get a unit cell where you can get an, anyway, I don't need to get into the chemistry exactly behind this, but you can get a really, really nice crystal that is very, very well defined and repeatable over the whole length of the actual physical object. So you can see on this sort of graph here beneath the growing crystals section, the time scale we're talking about is hours, and we are very, very slowly ramping down that temperature, right? Because as you slowly ramp down your temperature, the amount of dissolved solute, in this case THCA, that can remain in your solvent goes down as well. So as you really slowly let that fall out of solution, it will just perfectly align over a period of time, but it needs a long time to grow these nice crystals, right? Whereas if we look at the right-hand side, where we're talking about crashing amorphous crystals, or precipitation is sort of where I would go with this, but I understand the desire to keep the word crystallization. We're talking on the time scale of more like 1 to 3 hours total to get the amorphous crystals coming out of there. And you can see we are ramping down our temperature drastically and a lot colder. So what we're doing, instead of allowing the molecules to slowly build like you'd want to build those sort of bricks row over row on your house, we are just kind of trying to throw them together in a random pattern, but so that they fall out of solution. And what you can do there is basically, again, you're dropping that temperature so that you drop that solubility coefficient of the solute, and you wind up getting this sort of powder white material, right? The main difference is essentially that you can go faster when producing amorphous crystals, but if you go too fast, you can wind up entraining undesirable compounds in there, right? So I've seen two sort of main issues with this. Is one, you go way too quickly on your cooling ramp rate, and what winds up happening is you either don't get a crash, which always freaks people out, or you get a crash and your crystals come out and they are like yellow or like brown. And then you have to rinse a whole ton of times. And I've found that you lose about 3% of your yield per 20 liters of butane that you pass over your crystals. So you can imagine if I have to rinse with like 100 liters of butane, I'm talking about losing like 15% of my yield, right? That's not so great. So you kind of want to find this happy medium where you're slowing, you have a reasonably slow ramp rate, but it's still quick enough that you're not sitting there twiddling your thumbs for 6 to 10 hours at a time, right? The other thing I've seen happen, and we'll talk about this when we get to the seed port a little bit more, but the other thing I've seen happen is you could either have impurities in your system that could do this, or I believe there is a terpene that precipitates before THCA. And what winds up happening is those impurities, or the terpene that I'm speaking of, I don't know which one it is yet, I'm trying to figure that out, but it will create a nucleation site and then will entrain whatever color that terpene or that impurity is in your crystal, because you're basically creating the foundation for your house, and all those bricks that are just dissolved in solution go, ooh, here's a place I could land. And they wind up landing on that impurity. And so it creates a faster crash, but it leaves you with a bit of a bad color. So I just wanted to sort of mention that, like, making sure that your filtration leading up to the crystallization is quite important. And then also at some point when I figure out what this terpene is, I'll try to let people know, because I figure avoiding strains with that when you're trying to make isolate is worth our time. Yeah.
Right. Thanks, Art. Real quick too, just to throw out there, we have a really good resource ebook just on really goes deep into THCA crystallization that Evolve's created. If you want a copy of that sent to you, just type ebook in the chat and we'll email that out to you after the webinar as well. So yeah, moving on from here, this is just some similar concepts on small scale. It's the same temperature chart. We just have focused on small scale glassware in this. I don't know if we want to talk through anything in here. I definitely want us to get to the Q&A. So if we're okay to kind of skip through to the larger stuff, we can roll through.
Yeah, I think the key there is to just note that what we did in a jar is not different than what we're doing in a reactor in,
right.
The mechanical, physical activity that's happening inside and the temperature control. Well, I should say the temperature conditions. The difference is whether or not we were in control of those conditions and how
right.
fast they moved. So, the jar tech worked, but it worked based on having a perfect everything leading up to it. And then as we scale it up, now we have the ability to not be limited by that input material perfection and instead actually modify the purity as we go.
Absolutely. Yeah, medium scale, this would be something like your diamond miners. And then finally we get to industrial scale, which would basically be your reaction vessels. So this is Evolve's solution to that. This is our controlled crystallization reactor. You can see on the left side is the crystallization port of the reactor with the agitator on top. The right side is a separatory vessel to funnel all of our HTE through. And all of this color-coded manifolding that Murphy loves on the front is all insulated and color-coded just for ease of operation for the end user, and allows us to color code and really like get away from plugging hoses into quick connects and changing this to there. We can just control everything on this reactor, what solution's flowing from a top port to a bottom port, or bottom to bottom, or top to top. Depending on what you're doing, you can just do all that at chest level with this color-coded manifold. So an easy solution.
And it's in front of you. Let's talk about that. I don't have to reach or climb or get a stool.
Yeah.
I probably do have to get a stool, but you know.
Yeah, you might. Yeah. Yeah, and then on the right, it's kind of a picture inside of the crystallization side of the reactor. That's obviously further on through the precipitation of THCA, and you can see some of the HTE floating around in there with it. This is a better kind of, you want to talk us through what we're looking at here, Hart? This is like a kind of precipitation happening in real time, and I can just keep looping the video while you're talking about it.
Yeah, so basically what winds up happening is slowly you're growing these crystals, right? And let's imagine your HTE was sort of red, or your crude was red at first, right? What will wind up happening is as you add the white crystals in there, you'll see that it'll start to turn kind of brown as the color sort of, as you can see in the beginning of this video. And then what winds up happening is slowly as you get more and more white precipitate forming, those color containing compounds are becoming less and less obvious and sort of mixing in a little differently. And you wind up basically, you can almost build a castle of THCA within your crude, which is kind of a cool thing to see. This is when you've boiled it down quite low. But what we're seeing essentially is the slow precipitation of THCA, where you see this sort of like white, precipitate just slowly taking over all that HTE. All that color containing compound is still in there. You just have to sort of filter it and rinse it off. But yeah, that's basically what we're seeing.
Beautiful. Yeah, and the steps leading up to that is kind of this next piece we're going to show. And this is really the exciting part in some of the areas we've changed in the webinar. Definitely want Hart and Murphy to talk on this one, but let's just lead with, these are the old process steps from the original method of crystallization. So we're going to review those quickly and then get into what's changed, what's happening today, to even refine this process a little bit even further. So, all right, you want to talk about?
I can talk about the first process. That way, Hart can lead us through what has changed. So, for anyone who's watched this webinar or attended any of the courses before, we've been promoting this. This is like 2023 tech, right? Where we had kind of two goals. One was just we need to scale up our batch size. And the other was that we needed to improve the time and the efficiency. And so crashing faster isn't always the same as crashing purer. And especially in that Canadian R&D license, boy, let me tell you, input material quality was not a feature of original experiment designs. We were specializing in old, dirty super sack weed. So the process was really anchored in, accessibility. So it was number one, we start with crude. We concentrate it, we recover it. That gives us our saturation point where we're approaching saturation. Then we see that crystallization, that precipitation that Hart was just talking about. And depending on the quality, sometimes the first thing we're going to do is rinse it off again. Every once in a while, you get lucky, you have some really fine input material and it's good to go. But the rest of the time, we're repeating. And so the original reactor was designed to give you the flexibility to repeat until you achieve your desired output. There was always two vessels so that we could move what we were rinsing off into another vessel in order to keep the crystallization going. And so sometimes what we're removing is HTE, which is good and great, and we can recover the butane out, pour that into a jar and set it aside. Sometimes what we're removing is sort of that rinse that may need to also be recrystallized on its own. But the goal really was a repetition model where we are bringing it down to saturation and then crystallizing a little bit faster each time with the goal of separating more impurities. And so it was really a subtraction process where we crystallize and then we remove, and then we crystallize and then we remove. And we want to crystallize just enough each time so that it's staying pure over here, and we can just add a little bit more purity from what we rinsed off each time. The process was really built around that, scale up for old bad material. And I would say that's in part because that's what we had access to up in Canada, but also in part because that's where the industry was shifting, and the people who were asking for scale up weren't really doing it with boutique fire fresh frozen. And so, that old process was all about getting to fine white isolate faster, really trying to do what the CBD and hemp industry had been doing for years, but easier. We wanted to do it with our propane.
Absolutely. And this chart, just the old process temperatures kind of correlate to the ramp up and down through all of those processes you just saw. So the same areas: concentrate, crystallize, rinse, redissolve. These have changed, obviously. So, moving on next, Hart's going to talk about the updated process steps, and now we have some nice videos that can reflect these as well. So as you talk through them, Hart, I'll play these videos.
Awesome. Thanks, Swiss. I was just going to mention on that last slide, previously, crystallizations with the old method, the fastest I could get them to go was about 3 hours, I would say, start to finish. And that was
which was incredible, by the way. At the time in 2023, people
100%.
were putting stuff in jars for 6 weeks.
Oh, yeah.
So.
Yeah. Wait, I'm not trying to knock 3 hours. All I'm saying is I've cut that time in half, and that feels great. You know what I mean? Like we're at a position where we're doing quite well. So the initial step here is still fairly similar. We're concentrating and recovering. We're now not concentrating all the way down to a point where we've removed 99% of the butane. We are oftentimes getting down to that point and then re-adding butane to make sure we have enough solvent to sort of pull more of the impurities away in that initial and now only crystallization that we have to do to get this material that's, THCA at a higher purity, higher than 98%. And so that first video there is just sort of looking at the crude of some fresh frozen that we had. The next thing we do, very similar to what we did before, we slowly ramp down at a reasonably rapid rate. And you can see here we get a crystallization to take place. There it kind of looks like a little mocha or something, you know what I mean? A little like cappuccino of some kind. That will keep a little bit more color because we have more butane in it. So it sort of spreads out the HTE a little more, I find. So you just get a little more color staying visible. The thing we do after that is, instead of filtering through a 6-inch filter gasket at the bottom, we now fire that over to our basket filter. So here is a slurry of THCA dissolved in a mixture of butane and HTE, flowing through a 3/4 inch line into a nice stainless steel basket filter that we can just filter through. Instead of having a 6-inch surface area, a 6-inch diameter circle as our surface area, we now have that as well as a whole cylinder to create a lot more filtering power. So that's dropped our rinsing and washing time drastically. And I find that because the HTE isn't just sitting on the isolate, it doesn't sort of stick to the outside as much, it just tends to flow right off, and you maybe need to rinse one time to get the purity you're looking for. The final thing is no more redissolve. You're also not just opening up the bottom and hammering into the side of your reactor with a screwdriver or something. You just pull a basket out and then you dump it out. Obviously, make sure your basket is grounded. I think we all understand we have to be safe, but it's as easy as that, right? It comes out reasonably dry, still has to go into a vacuum oven. I'm not going to sit here and say we remove 100% of the butane. We have a way to do that if you need to, but anyway, so you pull out this nice white powder. You're not needing to do a pour off. You're not needing to like hammer and chisel your way out of something like you're in 2000 BC writing in stones. It's a lot more convenient these days. And the two main upgrades we made to the process, in my opinion, are the basket filter, which makes the rinsing a lot easier, and the guesswork that we took out by adding a seed port. So when we're talking about nucleation, building those bricks, you'll remember I mentioned about the impurities or a terpene that I find can sort of create a nucleation site. Now, what we're doing instead is purposefully putting a nucleating agent in there. It just so happens to be THCA crystals. So we drop those in with a little butterfly valve. They create the foundation for everything to build off of. And now those bricks just stack up unbelievably quickly. It's taken a ton of guesswork away from operators, where before you were just dropping 5 degrees at a time, hoping you see a precipitation start. Here, you run down to a temperature that we like, about like -8, -10 Celsius. drop in some seed crystals, wait 5 minutes, you've got a precipitation happening. You're not sitting there twiddling your thumbs for a few hours guessing. It's
yeah, and just to add onto the basket filter too, like it's such a good upgrade. I mean, doing it from the old way compared to that is night and day. I can't imagine going back and trying to manually harvest isolate out of the reactor by itself. The transfer loss, the time, my back, you know. But yeah, like outside of being able to harvest that easily, it's Hart touched on it, but the rinsing process is much simplified and much easier with this as well. Once we separate HTE through that basket filter, all the solvent HTE can be rerouted to our separatory vessel, and then we can just wash cold butane right over the crystals already in the basket. Make sure the butane's cold enough so we don't redissolve anything. We just work to crystallize, obviously. But that's so much easier than all the other ways to do it. And we can just do this repeatedly. Again, it goes back to simplifying SOPs and simplifying processes. And there's many benefits with that basket filter, but just the ability to wash easily and harvest easily just shaves serious amounts of time off the process. And we actually have some better videos of it too, but I'll move on to those here. But first, I don't know if you wanted to touch, Hart, on some of the updated process temperatures now that we've eliminated some of the, the prior process.
Real quick, someone asked how much can you fit in the basket? Could you answer that?
Yes,
before
absolutely.
we move on.
So we have two sizes of basket filter. One is a 6-inch diameter, and we can fit definitely 2.5 kilos in there. You're full. You don't want to go bigger than that in an individual basket, in an individual 6-inch basket filter. We also make an 8-inch variety where you can fit about 5 kilos. So what we have some clients doing, they're running 10 or 12 kilogram crystallizations in our vessels, and they just have two 8-inch basket filters. Put one in, filter call it about half their material, pull that out, dump it out, have their second basket go right in, filter most of the rest of their material. And while they're doing that filtration, empty out that first one. If they need a little more, they put that first one back in to get that last, let's say, you have 12 kilos. You can get.
Yeah,
that's a key point. Terrence brought up right afterwards, saying that in his experience, baskets don't filter well because everything runs off the side. So I'm glad you brought up already, Hart, that a lot of times that basket filter, the sizing of it matters, but you don't always know how much THCA is going to be in that reactor before you start if you have an integrated system that's completely in line. So you may not have a total grams of THCA that you're expecting in and out, which is why I like to have those COAs so much, so I can try to predict it. But let's say that there's no hope of having that info. That's where I think multiple baskets goes a long way, because you have to compensate first for the physical volume of the basket, but then second for the flow rate at which you want it to filter. And so I have also experienced basket filters not filtering well. And the two reasons are almost always that they are not properly cleaned, so they're sticky, they clog quick, or they're being overfilled and then therefore overpressurized to push it through. And what you really want is to have enough space and maybe redundancy to give it time. So rather than repeating redissolves, you just sort of divide your batch out across these basket filters so that you're not having to go over and over.
Yeah.
Great point. Thank you, Murphy. Okay, so moving on. Hart just started touching on the seed port. This is, I'll let you discuss it, Hart, but yeah, this is another new item we've come out with to add on to our crystallization reactors. That's a lower cost item that really is a no-brainer, can shave significant amount of times off each crystallization process. I'll play the video, and Hart's been playing around with this in the R&D lab more than anybody. So, tell us all about it.
Yeah, so the video I think is just sort of showing the filtration at the end, or it's just showing crystallization. So unfortunately, what I wind up doing is I only add a maximum of about 5 grams of THCA into my seed port, which means you kind of see a faint little snow falling down, but it's very, very hard to see in a video. But basically, what you can see in this middle image is our version 1.0, let's call it. This is where I just took a bunch of stuff off our R&D shelf and built it to sort of try things. But so we have a black valve at the top that is going into a 3/8 inch to 1.5 inch tri-clamp with a filter gasket on it. That leads to our vacuum line, which means that when I open that tri-clamp up, I can just load in my seed on top of that blue butterfly valve. Let's say I'm loading in between 2 and 3 grams for any given batch. Then put that tri-clamp back on, pull vacuum. That way I'm not introducing any water, any moisture into my system when it's cold. And I'm ensuring that with that filter gasket, I'm ensuring I'm not just blowing my seed out the back of my Venturi pump. Then you can see once I'm at the temperature that I want, once I've reached super saturation of my THCA in my butane, I flip that butterfly valve over. The seed kind of flies down this slight angle, falls into the solution, and within 5 minutes, I've got a precipitation happening. What I've got shown on the right is just sort of an updated client-ready version of the seed port. This is sort of built and designed a little more thoughtfully, as opposed to just me kind of MacGyvering a system together to try and prove the concept. It basically has a large ball valve on it, a large port, so you can get, you'll see the 1.5 inch to 2 inch reducer or adapter on there. That means you can fit between 50 and 60 grams of THCA in there if you want. It's a lot more seed than you need, but it affords you the space to fit whatever you want into there, and gives you a little more space to pull vacuum on as well, which I like. And then we just have that T off of there just to make sure you still have a pressure gauge sitting on your vessel there for safety.
Right. Can you speak a little bit to when in the process you add those seeds?
Absolutely. So the time that I like to add the seed is once I am reducing the volume of butane in my reactor, getting ready for the precipitation reaction. Basically, I find that's a convenient time because I'm kind of just sitting there waiting for butane to boil. And so I can just quickly open up that tri-clamp, weigh out my seed, toss it in the top, close it back up, pull vacuum. I'm not pulling vacuum anywhere else on the system at that time, at least in my workflow. But really, it's something that if you know 2 minutes before you're ready to seed, that's as long as it takes, which is kind of a great part of it, right? It's as easy as take a little wrench, open up a single tri-clamp, throw a little white powder in there, close it down, pull vacuum for 30 seconds to a minute. You got it done. It's it's a really nice, quick, easy process. And it's, I kind of think it can fit anywhere in a client's workflow, which is, kind of a big feature of it, I think.
Awesome. Thanks, Art. And this is the updated process flow. So you want to speak on that? That'd be great, Art. And then, Terrence, this probably correlates with a question he just put in here. Terrence says, I saw on the previous slide your time versus temp chart. We are not able to stay in the metastable zone following that ramp. How are you able to stay in the metastable zone with those parameters?
Okay, so it's a great point. So with these parameters, it's not exactly how I do things. So what I do is I go from 20 degrees Celsius on my concentration step, then I immediately just plummet to -10. As soon as I've hit -8 internal on my temperature probe, that's when I'm flipping that butterfly valve and adding seed. I let it sit at -10 for probably 20 minutes. Then I'm dropping it fairly quickly in 10 degrees Celsius increments down to -30. Then I'm sending it off to the basket filter to rinse. So this process flow, this graph is just sort of more representative of the temperatures we achieve and the steps. It's not an exact sort of scientific view of exactly what we do, but I'd be happy to go over it.
Yeah, it's not quite a recipe, that you can follow minute for minute, kind of like cooking times may vary, but one thing I think is really important is that the thermocouple that these temperatures are being measured is inside the solution. This is not a chiller set point. This is not a heater set point. This is the temperature of the solution. And I find that a lot of people talk about their temperatures of their process as though those two are interchangeable, which they are not. And so, everyone should be able to experience similar outcomes if they had identical input, identical internal conditions, and identical sized batches. The likelihood that those three things are ever going to be true for two people anywhere, not great. But to get close to that and get close to being able to repeat what someone else has done, it really does require that you know your internal temperatures, because the temperature that you have to set your chiller to in order to actually drop to that -10 is going to be different for every chiller and every vessel and every room. Do you have a 95 degree C1V1 in an Oklahoma summer? You're going to need a different set point. Is it 0 degrees outside because we're in Ontario in the winter time and we're turning on the chiller just to warm ourselves in the classroom,
Yeah.
then we need a different set point. And the reason we make those decisions is largely based on that internal thermometer. And I think back to, Evolved integrating into your systems, even if you have another crystallizer from someone else, call Evolved and have them build you a bottom cup with a thermometer so that you can actually control your process, because you can't control what you can't measure, and you can't measure the inside from the outside. Just not how that works. Lasers don't count. Laser through the sight glass, not going to cut it. It needs to be a probe inside, because those decisions that you're making, like you said, when you hit 8, that it's time for you to make a decision. For someone else, the time between 8 and 10 might be longer because the BTUs on their chiller.
Yeah.
Because the size of their jacket, because the distance it has to travel down the hall, because they don't have insulation, et cetera, et cetera, et cetera. And so it's not necessarily a recipe you follow exactly, but it is a pattern of conditions that you want to imitate. And you've got to have that internal thermocouple. If you can't measure inside, it's really hard for you to respond early enough. And you inherently have a delta between your set point and your process. But you need to know that delta to actually design around it.
Right.
100%.
Great point. Thanks, Murphy. Okay, so moving on, the THCA filter unit, this is just some more video and information about it. I don't know where this one on the right's playing. So on the right here, you can see solution coming through the sight glass. So visibility in the process is obviously important to see what level we're at inside of the vessel. Art had mentioned earlier, we have a 6 and 8 inch version of this vessel. Just obviously depending on scale and throughput is usually the deciding factor if we're going to run a 6 or an 8 inch or multiple basket filters, just depending on the situation. And I think this is a video actually of you, Hart, up here on the corner. You want to just talk through kind of harvesting out of the basket and the way you like to do it?
Yeah. So it's pretty straightforward. It's just got the spool on the top there has 2 tri-clamps. I like to leave it under vacuum slightly, remove both of those tri-clamps while it's still under vacuum, just because the jacket is actually chilled. And what I wind up doing then is break the vacuum right when I'm ready to take it out, move that cap off. We've got a little stand that you can put it on, then pull out the actual basket filter itself. And I've got a long spatula, sort of silicone, platinum cured silicone spatula that I can scoop in there and then just dump it out. This was for a client demo, so I'm dumping it out onto a tray, but obviously if you're going to be putting it into Pyrex to put into a vacuum oven, that's sort of up to the client. But then also we have, the option of just dumping it right into a C-vault, which you can see in the bottom right there. I think that top video was me using our first iteration of the basket filter. We sort of made a new iteration that makes the welding a little simpler and sort of makes the actual integrity of the basket filter a little bit better. We increased the popping pressure by something like 20 or 25 psi, which is a pretty big deal when we're talking about a filter. You know what I mean?
Right.
And so you can see there that basically, I'm just sort of putting my hand in and scooping it out. It's a fairly quick and painless process. And it comes out sort of like wet sand, basically.
Yeah, thanks, Art. And yeah, guys, we are a little right over time here, but not to worry. We can stick on and do some of the Q&A here. This last piece, any technical questions or want to get in touch with us, contact information's right here. Everyone that already commented demo or ebook or want any of the resources we talked about earlier, don't worry, we've got you saved in the chat here and we'll be reaching out after. But yeah, we can start with some of the Q&A. Ben is at, it's a QA compliance question. This is right up Murphy's. Oh, looks like she already answered too. So
yeah, I was so excited. But it is a good question. I think is worth discussing. And Hart can probably speak to this even from the regular chemistry world, because we like to complain about our cannabis compliance and how much they want us to track from seed to sale. But in traditional GMP manufacturing, this kind of batch specificity is necessary. So Ben asked, how do we deal with seed material in essentially in our record keeping, because we're combining batches. And so now we've got to have all the data and the historical information and testing for the seed material, as well as the next material. And, you know, if we were to think about a cannabis recall, for example, if, you know, if a batch of flower got recalled for a pesticide issue and we had that flower and then we processed and it went and it went and it went, now the batch that we seeded with could be affected by, you know, contamination from the batch before that. And so there is a real risk from, you know, a quality control and compliance perspective. And so what I had just answered in the chat is that I like to recommend doing a test batch when you get a large lot. So you do a small extraction, a small crystallization, confirms your parameters, and then you seed the rest of that lot with THCA from your test batch. That way you never have to cross batches. It's a little extra work to do that original test run, but man, if you do it, you are going to eliminate a lot of rework. You know, for a long time, the crystallization process first just happened to us. Then we learned how to redissolve and repeat it. And then we just sort of expected to have to do it over again. The goal is certainly to predict it and replicate it. And we get closer and closer to that every day. And I think the seed method has a lot of potential for cleaning that up for people in their process and really predicting and controlling that process. But it does come with a pretty big burden of, you know, qualifying that seed material, let alone keeping track of it and monitoring it from batch to batch, which is another, I think, really good reason to keep the volume of the seed really small. You don't really seed faster or crystallize faster by adding more seeds. I think if anything, you just end up with residue on your butterfly valve probably. And so, you know, being able to seed from the same input batch is the easiest way to approach that. Every other method is going to be as complicated as the person who does that reporting is willing to tolerate. And if there's one thing you don't want to do, it's speed up the production process in order to make time for filling out worksheets. That doesn't count as going faster for me, in my opinion. You know, so it is a complicated, you know, problem, but it's easiest solved by keeping it within the family. You know, do a little test run, get a little bit of seed, qualify it. You know, it's still Amazon Prime Day for a few more hours. Great time to go buy a cheap microscope, you know, where you can measure crystal size and check it out. But keeping it within the same family, I think, is going to be the easiest way to deal with it. And I have that same answer anytime people are talking about formulating for vapes or, you know, adding HTE for shatter. Anytime you can keep it within the same batch, that is the easiest answer for compliance. And so, you know, while we do want to have this robust ingredient world, if you can't qualify all your ingredients on the shelf, you're going to run into issues downstream. So your responsibility really is to make sure that you have absolute confidence that adding 5 grams of THCA from any batch is going to have the same impact on the future batches you apply it to. You know, theoretically, you shouldn't have any, you know, pesticide or microbial issues. In my opinion, one of the biggest risks of recontamination is heavy metals, because it is very hard to test for them. First of all, it's complicated acid digestion, but also it's not a homogeneous contamination. And so, you know, metals would be the one I would be the most worried about coming from a prior seed batch. And that's why, again, small quantities, so that diluted across your whole batch, it would be impossible to pull a sample that's going to surprise fail you for arsenic or something like that.
Right. Interesting. Another one just popped up. Parker asks, how do you make more granular isolate? And looks like Hart has already answered too. Adding seed makes a much more granular isolate, usually in the 100 micron range for our precipitated material. Just wanted to share that because I've seen that come up a couple times in the question thread. If there's more to cover there, feel free, Hart, or if it's not clear, just add another question in the chat box, all the attendees. Okay, scrolling through all the questions as well.
Yeah, one thing I want to touch on with the granular isolate is that as the industry develops, we love making up new names for our products. But one thing I would love to encourage everyone to do, again, I love a microscope, you can get a nice little micrometer for your microscope where you could just place your isolate on it and easily measure the size of it visually, which is great because then you get to look at it, you get to take a little picture of it. It's fun. People are willing to do this task in the lab. That's a big component for me. But if we could all get on the same page about how we measure and therefore how we describe our THC isolate, boy, oh boy, that would be nice. Because a lot of times I'm trying to use words like, is it powdered? And powdered to me is the difference between refined sugar and powdered sugar and brown sugar and sugar in the raw. But some people will say powdered about something that is sugar in the raw plus powdered sugar, you know? And so like the consistency of the crystal size throughout the batch is important, but then describing that crystal size, I think, is really the next step for how we, you know, move this more towards a commercial ingredient manufacturing for anyone who's looking at their Schedule 3 transition, anyone who's looking at international exports. There is a future where these isolates are going to be characterized by their size. And the sooner we can all get on the same page about if we're going to describe those by like their physical, you know, descriptions or come up with some standard sizes that we all like, the better. I know there's going to be a lot of inclination from people's marketing departments to call them space dust and super sugar and whatever, sparkly sunshine, whatever you got. But there's a lot of value in us all getting on the same page about how we describe these and then also how we measure it, because it can go in a lot of different directions.
Right, right. Okay, we've got another question in here. What are the main comparison in yield and potency between outdoor versus indoor material? Any problematic contamination in outdoor cannabis or outdoor weed? I'm guessing this is related to the isolate. Yeah, I think it's the same thing we were talking about in the webinar earlier. It's going to come down to getting COAs of that flower and seeing what cannabinoids are present in the material. Because like Murphy had mentioned earlier, one of the benefits is not being tied to the quality of the flower anymore with isolation. Like the THCA that's available in that flower, ideally we can remove and crystallize and trash the rest. You might not get the best HTE fraction off that material if it's outdoor material that's been sitting in a garage in a super sack in 90-degree heat for 6 months or whatever. But yeah, like Murphy was talking about, the input has a dramatic impact on the output, except when it comes to crystallization, right? So I think yield is really the only factor that's going to be different here if we're talking about isolate specifically. You guys got anything to add to that? I hope that's the question too, or if you're talking about just yields and primary extraction, that's a whole different subject. But yeah, it's not clear if they're into isolate.
And it's hard to kind of take, like, there was a long time in the early days, when I think back to like making wax Swiss back in the old days, where the idea, we were in Colorado, right? So outdoor weed meant California. It didn't even mean Colorado weed, right? And so there's sort of this way we talk about outdoor weed as if that is one thing. But now today there's outdoor weed in Colorado. There's outdoor weed in Maine. There's outdoor weed everywhere. And the outdoor weed is not one category anymore. So for something that gets harvested early because the rains are coming versus something that can go its full length because it's in the perfect climate is going to have a huge influence over, is there a lot of CBG left in it by the time we harvest? Is there a lot of Delta 9 in it by the time we harvest? Some of that is influenced by genetics, but a lot of it is influenced by when we harvest. And I think that's something that has sort of gotten diluted, and we sort of don't talk about it anymore because so many of us are just harvesting on the day we were told to harvest, and, it's not about, like, I remember talking a lot about when it was ready in the early part of my career, and now it is ready on the Thursday it was scheduled for, like we've stopped listening to the plant on readiness. And so where we may have had more genetic variation and more diversity in that cannabinoid content in the past, it has so much more to do now, I think, with just the methods that are used. And that's why, you know, Swizz, when you talked about outdoor, your first thought was people are going to store it poorly. Theoretically, you could store it, you know, you could dry and cure and store it the same as indoor and treat it perfectly, and then it's going to behave perfectly. If you grow in a fantastic indoor environment and you also store it like a jerk in a black trash bag in a hot room for a long time, we're going to have the same struggles. So I think the quality of the material, especially now for the commercialized industry, has so much more to do with like, what is your, you know, what does your care and quality control process look like? Are you feeding things and, you know, watering them in a way that's going to benefit us in extraction later? Are you harvesting in a way that's going to benefit us in extraction later? Are you storing it in a way that it's going to retain those qualities by the time it reaches us in extraction? You know, and all of that contributes to our preparedness, because while I may need to use a different size filter to keep the dust out of, you know, some really old outdoor material in my initial extraction compared to some fresh frozen or some really high quality recently harvested, you know, indoor material, that doesn't necessarily have anything to do with the fact that it was outdoor so much as the way it was stored and managed. And the key for me is just knowing it before I start, because there's a lot of problems you can fix in extraction so that they don't influence crystallization.
Right. Thanks, Murphy. We just had a couple of really good questions pop up from Danny as well. He's asking, sorry, let me just open them up here. Okay, well, yeah, I think Hart just answered one of them, but you know, how are we approaching the growing trend for solventless and consumers' fears of residual hydrocarbons? That's some education is the answer, but yeah, that's something we've been facing since hydrocarbon extraction has been in cannabis, period. I know Murphy's pretty passionate about that subject specifically, so if you want to speak on that, go ahead. But before, he's got kind of a follow-up or
even the solventless guys wish they were crystallizing. They love to post pictures of their cloudy crystals, y'all.
Yeah.
But I think even in the solventless world, they've been pursuing purification just as hard as we were. And they used to do it by trying to have perfect trichomes. And then rosin hit the scene, and that completely changed solventless. Even Frenchie said rosin isn't hash, you know? And like that, even the solventless market is on the same trajectory, where I think we will see the solventless version of THCA become a big, stable, you know, percentage of their market. And there's a weird world where people are doing a lot of pH gradients in water to not use organic solvents, which is still chemistry. So I think fundamentally, if you're concerned with solvents, your concern is maybe chemistry that isn't accessible to you. It should be in the same category.
Yeah, what are the additives that are altering your pH? You know what I mean? Are these not the same things? I mean, I get they're literally different, but is it not then the same people who are saying, I don't like hydrocarbons? It's like, okay, if we're talking about like, you know.
Yeah, if you're pHing your water, then it's definitely a solvent, I think, is kind of how that would work. But we'll set aside the water as a solvent, you know.
Education's the answer. Don't buy into the, you know, the hype of one method trying to bash another. There's a place for everything. Look at the actual science and get some quality education from sources like us, or find your own sources. But it's very reminiscent of when hydrocarbon extraction first really started becoming a thing. This is what the CO2 guys did. You know, they demonized hydrocarbons 100%. And said hydrocarbons will kill you and it's poison. And, you know, like when we get to the end of our product, especially when we're talking about isolate, where's the solvent? Like everything has been long purged by that point. So, you know, just having a base level education to talk to clients or, you know, colleagues or whoever it is you have to have that conversation with is what I'd recommend. It's just, you know, education. Everything else out there is a lot of fluff and, you know, bro science, if you will. So
yeah, I think that's a great point though, that we don't have to you know, speak negatively about another method to promote our own. I think exactly. You know, the way you address it is to simply not have any residual solvents. Do a good job of your butane extraction, do a good job of your butane crystallization, and the product will speak for itself. We can't overcome the market preferences. What we can do, though, is promise you that they're going to change. So
Yeah.
even if it feels very anti-BHO in your market right now, that is
6
a
months from
moment in
now.
time. Yeah. And probably the catalyst for that change will be if you just keep doing a very good job, because what we can do better than solventless inherently is hold our quality standard from batch to batch. And that's because we are not so bound to the availability in the original starting material. So,
Right.
The way that we respond to solventless is really to just hold the line. Solventless is incredible. I think it's so amazing for people to be able to do themselves at home. I love that now someone at home with a rosin press can make their own THCA isolate. That's a delight. However, we're trying to feed the world. And the rest of us, really make up for that, and we'll deal with the stigma and, be ready to respond to the market trends by simply holding the quality line and continuing to do what we're best at, getting the best out of what's there.
Yeah. Danny had a really good follow-up, but we were kind of like naturally trailing into there. But his follow-up is more processing related question. He says, also, what's the best method for a batch of biomass? What percentage should be run dry versus fresh frozen when creating products that are specifically formulated from both isolate and HTE under that batch of biomass?
As much as you can fit in your freezer is how much should be fresh frozen.
Yeah.
Why would you risk improperly drying and curing? Why would you give it the opportunity to be exposed to more airborne pathogens and microbes if you don't have to? Is always, my first recommendation. But my second recommendation is to assume that your freezers could lose power and to only freeze as much as you can reasonably extract. So, if you have to store something long term, it's harder to guarantee and protect it if it's in fresh frozen format. It will last longer if it stays in a freezer. And that's all scientifically true. But the real world is that, a lot of people have lost a lot of good material over a freezer not turning back on after a power outage, over it accidentally getting, shut off because a breaker flipped. So, look at your freezer capacity. How much can you protect over time? How long do you have to store it when you're splitting up those batches? Fundamentally, everything about fresh frozen, I think, is better to extract in terms of the ease of use. I mean, you're getting a lower yield per grams in if we remove, if we consider the water content of it, but it's less dusty. That I've been working on an airborne allergen research study for occupational health and safety, and the difference, you guys, is disgusting in terms of what you're breathing in the air when you're handling dry material versus fresh frozen. And that is when handling material that is good that I would smoke on purpose. Just breathing that dust in, very risky. Dry material almost always is going to come with higher filtration demand because of the particle size, but also because that extra oxidation, essentially, that's occurring during the drying process. So, as much fresh frozen as possible, but just keep in mind that, you don't want to put more in a freezer than you can afford to lose.
Thanks, Murphy.
I was just going to maybe talk about that briefly, if that's okay. I was just going to say,
go ahead, Hart. Absolutely.
I find that a key parameter when I'm looking at biomass, because I'm with you, Murphy, you'll get a much better crude and you'll have an easier time telling if you're precipitating out of a fresh frozen lot of biomass, 100%. The thing that I am okay with about dry trim, for instance, is that if I can get the COA from that, and I know I have at least a 4-to-1 ratio of THCA to THC on a weight by weight percentage, I know I'll be able to get that to crystallize. Would I love it to be higher than 4-to-1? Absolutely. I'd love it to be in the 10-to-1, 20-to-1 range. Don't get me wrong. But I have reproducibly been able to do it at 3-to-1. So I like to tell people 4-to-1 just to not give them some kind of unrealistic expectation. But I find that you need to make sure you're getting that ratio right. So it's if you're saying, okay, my dry trim is 1-to-1, and I need to add in fresh frozen to hit a ratio that's going to crystallize so I can pull some some actual value out of this dry trim that otherwise I'm basically not going to use, or I'm going to have to send to like a lower value product. Yeah, I would say try to hit that 4-to-1 ratio, at least, ideally even higher. And so then it's just sort of talking about, sort of as Murphy's alluding to, you have to make sure you know you're like, whatever mass of dry trim you're getting in, you're getting a lot more crude out of that at the end, as opposed to the same mass of fresh frozen, because let's call it 70 to 80% is water. So you're needing to run a lot more fresh frozen in there to sort of recoup that THCA to THC ratio.
Yeah. One more thing I want to add to that, because Danny was also asking, if I have one batch and I'm choosing how much do I freeze, right? And this kind of comes back to that quality control question about the seeds we were discussing. And, inherently drying, especially if there isn't any curing, which is most of the time, we lose volatiles. There are aromatics that were present that are no longer present. And a lot of times we don't even really think about them because they've never been in the dry flower that we're smoking. It's fine. But for, separating a big batch at once, one thing that I think about a lot is, sorting your laundry is what I'll call it. But if I'm imagining one plant, the lowers, the small buds, the fluffy stuff, that is going to lose its aromatic content faster because it doesn't have the density. There's less trichomes on the inside, keeping things safe, when most of the bud itself is outside surface area. And so, while it's common for people, especially in the metric world, to say, let's say I have 50 plants, then I'm going to cut 20 of them and freeze them, and then you freeze the whole plant, and then I'm going to have 30 that we're going to, trim, have some flower, have some trim that needs processed, have some smalls that we sell for a crazy discount. If you could theoretically cut your tops for your flower and your bottoms and freeze, that would be the perfect way to go about it. I realize for a lot of quality control and record keeping reasons, that's an insane request. But if I wanted to actually optimize the profitability of my plant, what I would do is section it out by stuff that I could never sell in the jar and stuff that is going to create a dusty residue all over the rest of my life until it's gone. And so the small buds, the trim, anything that's fluffy, especially if you're pheno hunting, the fluffy stuff really is going to be better if you can freeze it right away compared to nice tight buds that just hold their flavor. And that's,
Right.
I think especially in the HTE world, sometimes you've got to really, batch to batch, you might have some strains that dump THCA with very little HTE. And you might have some batches, historically, the ones with the best flavors don't always have the most cannabinoid content. We can't all be perfect, And so sometimes the formulation is not just about ratio of THCA to HTE, but actually THCA from over here, these 50 plants, versus HTE from over here from these 50 plants. And so, being able to balance that in the cultivation is a luxury and a burden. Good luck,
Great points. Thanks, Murphy. Okay, guys, I know we're about half an hour over time here. I was scrolling through the questions. It looks like we've got everything answered. If we don't, we can probably squeeze one more in, just put it in right now. Again, too, if you missed putting any of the words in for any of the stuff we're going to send out, now's the chance to do that if you didn't earlier. Type demo if you want more information about coming up to the facility to see live demonstrations with biomass. Type ebook if you want the crystallization ebook sent to you, or just reach out. My direct contact information, swiss@evolvedextraction.com, is listed up here. You can find us on Instagram on our website. We're not hard to get a hold of. So I'll give just a second here to see if any more questions pop up before we wrap. But while we're waiting, just wanted to say thank you to Hart and Murphy for all the knowledge drop and being part of the webinar. And thanks to everyone that attended. We hope to see you again on the next one. Again, this whole thing's recorded, so if you want the recording, if you haven't already, just type recording or something like that in there, and we'll make sure to get that to you.
Swiss, thanks for moderating, man. Very, very fun.
Yeah.
No problem. Yeah.
Thanks everyone for questions.
We're getting it dialed into an hour and a half now. We're getting pretty good on an hour and a half, just 30 over. But That's okay. Thank you guys for sticking with us too, everybody that attended. Okay, cool.
Thanks.
We got a few more recording requests here. Awesome. Cool. All right, I think we can wrap up. Thanks again, everybody. Hope everyone has a great weekend, and we'll be in touch if you requested more information. Thank you.
Awesome.
Thanks
guys.
everybody.
All right.
See ya.